You've probably heard it your whole life. Nothing can travel faster than the speed of a light. But what if I told you the speed of light isn't as simple or as constant as you think? We're taught that light moves at exactly 299,792,458 meters per second. That number is drilled into textbooks and quoted in documentaries as if it's the sacred speed limit of the universe. But here's something most people don't realize. That number isn't just a measurement. It's actually built into the way we define our units of space. Since 1983, the meter has been defined in terms of how far light travels in a vacuum in a specific fraction of a second. That means we didn't just measure the speed of light and then set the meter. We did the opposite. We defined the meter so that light speed would be exactly that number. It's a fixed constant by definition. But here's where things get weird. That's the speed of light in a perfect vacuum. In real life, light almost never travels through a perfect vacuum. And when it moves through things like air, water, or glass, it actually slows down. In water, light moves at about 75% of its vacuum speed. In glass, even slower. And in laboratory conditions, scientists have used special materials to slow light down to walking speed. Literally. There have even been experiments where light was brought to a virtual standstill inside ultra-cold atomic clouds. So does that mean the speed of light isn't constant? Well, not exactly. What's really happening is that light interacts with atoms in these materials. It gets absorbed and re-emitted, causing delays. The actual photons still travel at their full speed between interactions, but the journey as a whole takes longer. So while it appears to move slower, its fundamental nature hasn't changed. By the way, if you like this content, remember to subscribe and like. It's a bit like trying to sprint through a crowd. You're still fast, but all the stopping and starting slows you down overall. But even more mind-bending is what Einstein discovered. That the speed of light in a vacuum is the same for everyone, no matter how fast they're moving. That idea that nothing can outrun a beam of light, and that all observers measure the same light speed, is what leads to time dilation, length contraction, and the breakdown of our intuitive sense of simultaneity. It's not just a speed limit. It's a rule that defines how time and space themselves behave. Now here's a twist. There are things that can move faster than light. Sort of. Particles moving through water can outpace the speed of light in that medium. This causes a blue glow known as Cherenkov radiation. It's not violating relativity because the particles aren't exceeding the vacuum speed of light. They're just going faster than light does in that specific material. And then there's quantum entanglement. Two particles can become connected in such a way that measuring one instantly affects the other, no matter the distance between them. That seems like information is moving faster than light, right? But no usable information is being sent, so relativity stays intact. For now. And here's the kicker. Some theories suggest that in the early universe, the speed of light may have been different. If that's true, it could reshape our entire understanding of cosmology, the Big Bang, and how the universe evolved. So the speed of light, while central to physics as we know it, might not be an eternal universal truth. It could be a local property of our current space-time, subject to change under extreme conditions. So the next time you hear someone say, "Nothing is faster than the speed of light," remember, that's only true in a vacuum, only under certain conditions, and only within our current understanding of physics. The speed of light is not just a number, it's a doorway into the very structure of reality. If you like this mind-expanding breakdown, be sure to give it a thumbs up, subscribe for more videos like this, and drop a comment below. What would you do if faster than light travel became possible? Thanks for watching, and stay curious.